So if that is all good, then yeah, we'll kick off.
Yeah, all good.
Cool. So good evening, everyone. I'm Simon Whiteley. Hello. So I'm English MVP, talk about lots of data platform things. I spend a lot of my time in data lakes, working with Databricks, shoving data into Azure SQL Data Warehouse. That whole thing that people are kind of calling the modern data warehouse, modern data platform, whatever you want to call it. It's that whole move from saying, you know, I've got a single SQL server and I'm using SSIS to transform data, enrich data, clean data, to orchestrate all my different jobs. And I'm now using the cloud. I'm using Microsoft Azure. And like, how do you do those things that we used to do? How do you orchestrate things? How do you clean data? How do you do ETL in this whole crazy modern world? And yeah, one of the big answers is Data Factory. So we're going to go spend the next kind of 50 minutes or so talking about a few different elements of Data Factory, how it fits together, a little bit of an intro to get people up to speed, and then some of the advanced things, the weird and wonderful stuff that's coming in. So yeah, let's crack on. So hopefully my clicker works. Here we go. Okay, so going to do that kickoff, bit of a recap, bit of a talk about what Data Factory is. So if you are brand new to Data Factory, just going to go really quickly over some of the terminology. So apologies, anyone is a Data Factory expert, but the next 10 minutes is going to be slightly dull, and then we'll get into the good stuff. So bit of the recap, talking about V2. So if you weren't using Data Factory a couple of years ago, you're probably not aware of how absolutely awful and terrible it used to be. And then this thing, Data Factory V2 came along and changed everything. So I'll talk a bit about the impact that had and the behaviors, the patterns that's unlocked. And then we're going to spend a bit of time talking about this new thing, this mapping data flow, which has kind of, again, shifted the paradigm of what we're doing with Data Factory a bit and has unlocked a load of new behaviors. And it's changed even this week. It's constantly in flux. So that's the plan. We've got an ambitious load of stuff to get through. So let's crack on. Okay, so that age-old question of what is Azure Data Factory? What does it actually do? So fundamentally, there's two main purposes behind it. You're either copying data, you're saying, I've got some data in one place, I want to move it to another place, and I'm not transforming, I'm not changing it. The structure of the data doesn't change. I'm just picking it up from one place and putting it down another. Now, it might be changing form there. I might be bringing it, as from the diagram, from a SQL database, landing it as flat files. I'm putting it from a zip file and landing it as text. I'm essentially moving data, maybe changing the form of the data, but the actual data doesn't change. I'm not editing any columns. I'm not dropping out any columns. And that's kind of one of the core first uses of Data Factory. Then on the flip side, you've got transformation, and that's normally done by something else. So that's Data Factory saying, actually, it's not going to do the work itself. It's going to trigger other things. It's going to call a store procedure. It's going to tell Databricks to go and do something. It's going to trigger a load into Azure SQL Data Warehouse. It's getting other things to do the work for it. So generally, doing one of those two things in Data Factory, you're either using Data Factory itself to copy data, or you're using Data Factory simply to trigger other things. And that's very similar to the way we used to use SSIS. You know, so you can use SSI Dataflow to move things, and yes, SSIS does some data transformation, but otherwise you can use it to orchestrate stuff. You could use it to kick off a load of stored procs. You can use it to run a load of SQL. And it's kind of that idea. It's a very similar thing. And important to know, behind the scenes, everything in Data Factory is actually JSON. So while you're building this thing, it is a graphical editor, and it feels nice and drag and droppy. And all it is doing is just building up various different JSON objects that these days you don't actually need to think about too much. And that is a beautiful thing, because Data Factory V1, you spent your life working, creating and handcrafting tons and tons of these JSON objects. Whereas now, that's all done for you. No behind the scenes, it is just building JSON for you, but you don't need to worry too much about what's in there. Okay, so the kind of things that we're doing in Data Factory, we're pulling data from a load of different places and landing it into the lake. So if you are that initial step of getting data and bringing it into Azure, Data Factory is one of the key components to do that. So Data Factory is very good at reaching out to loads of external sources and sucking data in. So it's got connectors for a load of, you can talk to a load of Amazon Web Services, you can talk to Redshift, you can talk to S3 buckets, talk to things like Dynamics, talk to Salesforce. It has a load of connectors to read data. Now, the number of places it can write data to is a lot smaller. So it's really good at going and getting that data, pulling it into your Azure estate. Not quite as good at pushing it out. It is kind of that going and grabbing things so that you can work on it in Azure. So you get a load of data, copy it, land it into one of the Azure data stores, kick off a load of transformation activities, be that a bit of custom C#, be it some SQL stuff, be it some big data things via Databricks, via Hadoop, and then land it into a final store. That's the kind of thing we tend to be doing. So kind of an initial acquisition stage, get some data, land it, transform it, get it into a bit of shape, and then put it into its final destination, which is kind of what we used to do all the time in normal ETL stuff. We'd normally have like a SQL server inside our warehouse. We'd have a staging database, a clean database, and a warehouse database. And we were doing similar activities. It's just these days, maybe we're using different services for it, and we're splitting that work up, which actually means we can be a hell of a lot more agile when we're doing that kind of thing. We can switch out how we're doing data acquisition and not have to change our downstream services. So it's kind of splitting the work up, passing it out to different services, using the appropriate tools for these different stages. And yeah, it's a little bit more complicated because we've got some more things in the mix, but it's a lot more powerful because of it. So that kind of ETL, essentially going from source to destination via a little bit of a path, that's the kind of thing that we're trying to do. Okay, so some basic terminology, so you can get you kind of familiar with it if you've never used it. So firstly, talking about these things called linked services. Now, we've said we're talking to all these different services. We're talking to lots of different things, be it Dynamics, be it Databricks, be it a data lake, be it a database. Now, linked services is how we know how to connect to each of these things. So in this little picture, I've got a picture of a database, I've got a lake, I've got some storage, I've got Databricks. I need to have a linked service for each of these to tell Data Factory how to talk to each of them. So very, very similar to SSIS connection managers. I just need to tell it, how am I connecting it? Am I using a username and password? Am I going to Azure Key Vault to go and get some credentials? Essentially, for each of the services, I need to save down some credentials and tell Data Factory how to go and connect to these different things. So linked services, just your connections. You need to set up one for each thing that you're talking about. It's fairly straightforward. Underneath our linked services, we've got things called data sets. Now, these generally live underneath a linked service. These are essentially telling it where to find data inside those linked services. So if I'm talking about a database, then my data set will point to a particular table or a particular stored procedure. If I'm talking about a data lake, then my data set might point to a particular folder or a set of files within there. Essentially, it's metadata pertaining to individual sets of data that live within those linked services. So I'm saying I want to copy some data, want to move data from one place to another. I need to say which bit of data and then which service to connect to. So you generally need both of those things when you're working with a lot of our various different movements. Activities, and these are the actual things that we want to do. What are the tasks that we want to run? So I might have a Databricks notebook activity, and I need to tell it a load of parameters. I need to tell it which Databricks notebook to run, a path to follow. I need to tell it a parameter to pass in. If I'm doing a stored procedure, I need to tell it any parameters to feed into that stored pro. Essentially, kind of each of the individual units of work I want Data Factory to do, I'm going to need one of these things called an activity that describes what I want to actually happen. And then finally, I've got my pipelines. Now, my pipelines are my workflows. That's my related set of all the different activities that I want to achieve. So I might have a copy data pipeline, I might have a transformation pipeline. Normally, I'd have a whole set of things that are interrelated. The same way as we think of an SSIS package, I'm going to have a lot of different components in there. I'm going to have precedence constraints linking them all together. And that's essentially what a pipeline is. A pipeline is our full set of workflows that join up lots of different activities. So to switch over and have a look at what it actually looks like when you're developing Data Factory, we've got the development tools. Now, one of the biggest pain points about this, one of the biggest complaints, is that this is not a Visual Studio-based development environment. So this is browser only. And it's kind of a bit of a trend in Azure in terms of some of the newer products, some of the kind of the new and funky ways of doing things. You don't get that nice kind of traditional Visual Studio idea. You don't bake it into the same solution as your database project and all of that kind of thing. So I've got a completely separate IDE. It's accessible through the Azure portal. But you can see actually, so when you look at what's actually happening in the center of the screen, I've got those different activities joined together. I've got failure paths. I've got various success paths. It's very familiar if you're used to how SSIS works. It's deliberately built that way as a fairly familiar tool, so you can pick it up and kind of get to grips with it very easily if you're coming from that SSIS background. So it's a bit of a balance. Quite sad that you can't do it offline. You can't do it in Visual Studio, but it is actually a very nice IDE now. It's actually sort of quite easy to pick up. It's very intuitive. And I think when you start working with it should be quite nice. One of the things you can do is link this back into source control. So whenever you're making changes, whenever you're doing any tweaks, you can commit that down. That will automatically add it to your repo, and then you'll be able to see it in your data in your project. So it is still source control linked. You can still write into your normal repo. It's it's not a complete Wild Westing off on its own. It's just when you're making changes, you don't make those changes within Visual Studio. You have to go through this IDE to do it properly. Or you can edit the JSON yourself if you really like that kind of thing. Okay, so when you've got these things built and deployed and you've hit go and you've triggered it, then it does have a monitoring window built in. So when each of these things is running, you've got a quick view to say, did it run? How long did it take? What was the result? You can dive in and see some lower level details around it. It's even got a bit of a dashboard built in, so you can see how many runs did I have, what succeeded, what failed. And actually it's starting to get pretty good. It's still very locked in. So you still have to be inside that Databricks workflow. You have to be drilling down into your monitoring tabs to see this stuff. So not completely ideal, but at least you can actually integrate this stuff and you can start sucking the data out now. So it does integrate into things like log analytics. So if you have a central log store, you can go and hook that stuff up. If you don't have a big enterprise log strategy, then at least it does have its own monitoring and it will automatically just start monitoring these things, start reporting on it. You can set up alerts to tell you if it fails. It has quite a nice entry-level thing just to get you started. Okay, so that was a whole lot of stuff thrown at you quite quickly. It's going to get worse. So the good old Microsoft marketing team came up with some terms for us. And we have this thing called the IRS, the Integration Runtimes. So all this means is compute. And it's a big scary name for it, but you've got lots of different things that are all called integration runtime. That's quite good just to get a little bit of familiarity around. So we've said that Data Factory will do some data copying for us. It'll pick data up and it'll move it from one place to another. And that has to run on some kind of compute. That needs to have a server sitting somewhere that's going to do that work for us. So that server, that compute, which is you only pay for when you're actually using it, and you pay for by the second as it kind of tots up of you moving data around, that is called your default integration runtime. And there's a couple of interesting things about that. So one, yes, it's just automatically used. So you don't have to set it up, you don't have to provision it, you don't have to decide how big it is. You don't even need to decide where it lives in the world. So one of the trickiest things when you're working with data in Azure and having lots of different regions is if you move data between different regions, it costs you money. There's an egress cost of picking data up from one region. Whenever it leaves that region and gets copied to somewhere else, you pay a little bit of money. Now, the default integration runtime is kind of funky in that it will automatically run in wherever the destination is. So if you build your data factory and you say, actually, I'm going to build my data factory in the UK, in UK South, and then you're moving data from West Europe to North Europe, or you're moving data just entirely within the US, actually it will automatically run within that region. So it picks the most sensible region to run this in to try and avoid any data egress. It's not going to suck it out of its source, bring it over to wherever you built the data factory, and then put it back over where the destination is and charge you money. It's automatically going to pick the shortest route where it can run that compute. Okay, so that bit of thing in the background that's built into Data Factory that does data movement for you is called the default integration runtime. And there's two more options, soon to be three when we get onto other things, but we'll wait for that. First is SSIS. So if you are going the old school route and you're using SSIS, you can now host SSIS under Data Factory, and that runs on this thing. It runs on the SSIS integration runtime, which is again just a batch of servers. It's some compute. It needs to be turned on in order to run SSIS packages for you, and that's essentially where your SSIS packages actually execute. Now, this is not auto-region. So wherever you decide to provision your SSIS integration runtime, the data, if it's doing a data flow inside your SSIS package, it's going to suck data from wherever it is to that region, do its processing, and then put it down in its destination. So be a little bit careful where you create that, and be very aware that that needs to be turned on. It doesn't turn on automatically. So you can say, hey, SSIS integration runtime, please turn on. And then when it's finished, you need to remember to turn it off again. Now, it used to take 20 minutes to turn on. I think it's gotten a little bit better these days. But it's still a little clunky. It's still not that reactive. So be a little bit careful when you're using SSIS. There are a couple of limitations in there. The final one is a self-hosted integration runtime, which used to be called the Data Management Gateway, which is different to the Power BI Gateway. But essentially, if you're trying to reach into your on-prem network, if you've got a corporate network and you need to get at data that's hidden inside of that, then you need a self-hosted integration runtime to do that. And that it has to be, it could be an Azure VM that's inside your VNet. It can be a local machine. It can be a virtual machine on-premise. Wherever that happens to be, it's essentially an application that you can install on a machine that you own, and then that will act as a bit of compute for you. So if you're trying to reach into a really, really secure database that's inside your network, you can use that to get the data, pull it out, and that'll push it back up to Data Factory for you. So you got 3 levels of integration runtimes. The default one for moving data for you, SSIS for hosting sys packages, and self-hosted for reaching into your network and doing any kind of on-prem secure networked stuff. So apologies, terrible terminology, but that's what we're living with. As a bit of background information for how that self-hosted thing's working, it's actually kind of interesting in terms of why it's secure. So one of the biggest things, if you're trying to say, I want to get hold of data that's inside my network, can I just open up a firewall hole into my SQL server? That's fine, right? Generally, InfoSec will say no and have a bit of a panic and kick you out the room. So the whole self-hosted integration runtime is a way of doing that securely. So essentially, in between that server that we've got and Data Factory, we're reaching and pushing out. So we're using an outbound firewall exception. So our self-hosted integration runtime is constantly reaching out and checking, going, do you need anything? Do you need any work? Do you need me to send anything? So it's checking a service bus that actually lies in between itself and Data Factory. If Data Factory needs something, it'll pop a message into that queue. The self-hosted integration runtime will see that message and then start sending data out. So it's acting as this kind of gateway barrier to prevent any kind of inbound connection. It's only outbound, but it is going to tunnel data for you. So if you've got, basically it's going to sit in between your servers and Data Factory, and all data is going to move to that gateway and then get pushed out. So you need to be a little bit careful about where you put it, latency, that kind of thing. You can now scale it out. So that's quite nice. You can load balance it across a couple of different nodes and use both failover and concurrent runs. And you can now push self-hosted integration runtimes to multiple Data Factories. So it's starting to get a bit more flexible. You can start to have a bit more of an enterprise style architecture of how you're getting data into Data Factory. But, it does have some limitations still. Okay, right, so let's have a super quick look at Data Factory, and then we'll get into the interesting stuff, the new patterns and all the good stuff. Okay, so hopefully this should just go straight in. There we go. Just wait for screens to update. Okay, cool. So this is our Data Factory runtime. If you've never used Data Factory, when you've gone and created it inside Azure, you'll see your basic Azure resource, and you've got this button down here saying author and monitor. So if you click on the author and monitor, you'll go straight to this Data Factory screen, and then we can start working with things from there. Okay, so I've got a little pencil at the side. So right on the side, I don't know how Zoom's going to work. Maybe it'll be happy, maybe it's not. Yeah, it seems happy. Okay, so I'm going to click on that author button, go through, and then that's going to take us to our editing window where we can start playing around with some stuff. Okay, so I've got lots of things here. You can see down the side, I've got a few of my different objects. So I've got pipelines, I've got data sets, I've got the data flows, which is the new element we'll talk about in a bit. The thing that's not immediately obvious is you don't have linked services here. So linked services are hidden off down this tab at the bottom called connections. So we go down to this connections bit, and then we can go and have a look at that, and we can see what's happening. So in connections, I've got a couple of tabs, I've got linked services, and I've got integration runtimes. So on my linked services, you can see I've got a few different things set up. These are the different elements that I want to connect to. So I've got one set up for a local database of mine, one set up for an Azure SQL database. I've got 2 different ways of connecting to my lake. So in my various different things I'm doing, these are the different services I need to tie together. And so I need to have created these linked services in order to work with them. So in Adventure Works, normal standard stuff. I've got a name for it. I need to tell it where that server lives, which database on that server to connect to. I'm manually hard coding my username and password at the moment because I'm a terrible person. I should be using Key Vault. But essentially, so for each of your linked services, it's a fairly straightforward thing to go through and work along. Okay, so linked services, fairly straightforward, fairly self-explanatory. Inside integration runtimes, so if I'm in here and I need to set up a new self-hosted integration runtime, setting up a gateway, then this is where I can do it. It's also the only place I can see if my gateways are active. So if I had an SSIS integration runtime, then I'd go in here and this is where I turn it on and off, or through PowerShell. So currently I've only got the auto one running, so I can work with that. Okay, so linked services, hidden away in your connection screens, generally self-explanatory. Then elsewise, I've got my data set set up. So all the different bits of data I want to go and connect to. So different tables on a database, different folders in my lake structure. I've got those set up. Again, I can just go and click create new data sets if I want to do new ones. And then pipelines, various different, quite simple examples I've got, I can go and take us through. So really, really simple example, nothing particularly crazy going on there. So the main thing I'm going to show us, I've got this database set up. So this is just classic AdventureWorks. I've got an AdventureWorks DB. I've got a few different tables in there. And I want to start getting some of this data out. So I've got my sales order header is one of the classic, really, really basic examples. And that's a table in my database that I want access to. So I've set that up as a data set. So inside my data factory, I've got a data set set up. So I've got, so I've called it ds_SQL sales order header. And I've had to point at the relevant link service, and I've just told it which table. So it gives me a drop down. I've selected the table that I need, and that's hard coded, pointing at that table. And that's now a reference to that particular data set. Fairly straightforward, nothing crazy going on. I've done the same on the other side. So I have somewhere pointing to a lake, a little bit more complicated. I had to give it a path where to go. I've had to tell it, I want you to build me a CSV. But essentially, I've built data sets hard coded on either side saying, pick up this table, move over there. And then inside my actual obvious demonstration, I've got my copy data activity. So this is inside a pipeline. I've just got a single activity, and that's pulling from one source and pointing to another source. Really, really straightforward, nothing particularly crazy. If you used Data Factory before, again, I apologize. It's the most simple example in the world. But I can just hit run, and then that's going to pick data up, pull it out of that database, and then push it into my lake. And that's like the most simple example of working with Data Factory known to man, but it's going to get a lot better. So let's have a whip back to the slides and talk about why things have changed. So that's how we used to do things, and that was kind of a very common example of the way we used to work, but things have changed a lot. So one of the, I guess, kind of big things is when people are using SSIS, this is kind of the old pattern. So if I was doing that, if I was using SSIS to copy data from somewhere, then I'd have a package for every single different one of my entities I was trying to pull over. So if I had 15 different tables in that database, I would have 15 different SSIS packages. So if I'm using SSIS, I can still do that. I've got an SSIS activity, and I need to have those two bits set up. So my SSIS integration runtime and my SSIS catalog. And I can do that. I can set this up, I can have a pipeline, point it at an SSIS package and run it. There is a little limitation. It's good to know if you're going to try and do that, is the age-old pattern, the age-old way of working of having that master SSIS package going off and calling a ton of different child SSIS packages. That is a terrible, terrible plan. Please never do that. The reason being is when you're using the SSIS integration runtime, you can specify clusters. I can say I want 8 different SSIS servers. But the moment I call a master package and that calls child packages, any child executions will happen on the same worker that called it. So it won't properly scale out. So if you are using SSIS, you want to go that route, then just make sure you do your master package things up at the Data Factory level. Have Data Factory calling all the child packages, and then it will at least scale out properly over your various different packages. But that's kind of, that's an old pattern. It's not dynamic, it's not fresh, it's not new. And it's kind of following this way that we used to do in V1. So back in V1, times were sad. If I had 5 different files or tables or different data entities to load, I would need 5 different pipelines. So this is the old pattern. Now, because we've got things like dynamic parameters, we've got variables that we can now pass into Data Factory, we can make things a hell of a lot more dynamic. So we can do this kind of stuff. So I can have a dynamic pipeline using parameters. I can have just an activity that says, well, just tell me which file to load. And then I pass a parameter into my pipeline and then pass that down and say, well, actually pick this one, pick this one. For this time, for this run, I want you to use file B. And that makes life a hell of a lot easier. You can imagine I've suddenly gone from having 5, 10, 15 different pipelines to having a single pipeline that I just call with different parameters. That alone is massive savings in terms of my code footprint. Now I can do some more advanced things. I've got a lookup activity. So I can go and look at a JSON file or a SQL store proc, or I can go and read a list of stuff from an Azure function. I can go off, get data from somewhere, and then use that to make a decision. So I can go and get a parameter and pull that back and do it almost like the SSIS environment style thing. So I can go and look at a config file, or I can even use it as a for each loop. So I can provide a list, an array of things into Data Factory and say, do it for each of these things. So I can give it a list. I can go and get a list of tables from a database, bring that list of tables back, and then say for each of these tables, run this activity and go through. Now, as I mentioned there, I've got the max DOP, that's the max degrees of parallelism. So by default, my for each will try and do 20 at once. It can go up to 50 at once. So it can be loading 50 different tables, running 50 different jobs, 50 different activities at once. So there's some patterns if you need to increase that and kind of you want to get around it. But just that as a basic of saying, hey, look, I want to load my tables from my database. Just run them all at once. Here's a list of tables. Go run through and do it. That makes a massive, massive difference. Okay, so some other things I can do. I can do execute a child pipeline. And that unlocks the same kind of patterns as the SSIS master child thing. It also means I can make pipelines that I then pass lots of parameters to. I can wrap that inside of for each and say, well, for each of these values in my array, pass this to my child pipeline and pass these along. I can make reusable pipelines. So I can have a pipeline I call in certain scenarios, such as error handling. There's lots of different things that's unlocked by that. And not just through other pipelines. I used to only be able to do things via time slice. So just it ran on a certain cadence, it ran every hour when a new data set came available. Now I can do things on a wall clock. So just, I don't care what's happened, just at 2 p.m. every day. Can you please just run my data factory? I can do that. But more importantly, I can use manual triggers. So I can kick off a data factory by using logic apps. I can build a reactive flow of when a file lands in blob storage, kick off my data factory. I can suddenly make Data Factory incredibly reactive to changes. So you can do that via a REST API, you can do it via a function, you can do it via logic apps and a whole slew of different things now. I can build into event grid. So whenever anything happens in Azure, I can get that to trigger a Data Factory to go and deal with it. And piecing some of these things together, so that reactive processing, the ability to run things from lists, the ability to pass parameters into child pipelines, suddenly you can piece these things together into actually quite advanced pipelines. Now, one question we normally get is, how does this actually work for CI/CD, source control, all of that thing? So just as a quick heads up for those not familiar, we can do quite nice Git integration. So Data Factory by default, it'll talk to GitHub, it'll talk to Azure DevOps if you're using Git behind it, which you should be. And then you can do that kind of feature branching. So we see people, lots of individual developers, each connecting to their own version, making some changes, syncing that into Git, and then there's some mechanism to automatically deploy that into the dev branch. And then from there, you can hook up in Azure DevOps. There's actually a publish that will automatically create a release branch for you that you can then push out into prod. And that, again, is kind of a very much more modern way of working than it used to be with Data Factory. So I'm not going to set up in my demo, so I can't show you that today. But again, we don't have that much time. Okay, so let's try and have a look at that thing that we looked at earlier. So that really super basic copy activity, moving things from one to another. How do we make that actually good? Okay, so back in my Data Factory. So we're going to use parameters. We're going to build parameters into this whole thing to actually make this work properly. So let's go back and have a look at our actual data sets. Okay, so I need to make a dynamic version of each of my data sets. So I had my sales order header data set, which is pointing at an Azure SQL database, using that linked service, but it's hard-coded to a table. So I've created a similar thing. I've created one I've called Dynamics. I've called it Dynamic SQL AdventureWorks. I've told it, go connect to AdventureWorks, but I've given a little bit of logic. I've told it a parameter, and it's done this automatically for me. So there's now a parameters tab. So on linked services, on data sets, on pipelines, various different places, I've got this tab called parameters. I can go in there and just add in parameters, tell it what I want that to be called, and then that's then available for me as a new parameter. So I've got this parameter called table name. I can give it a default. I can tell it what type of parameter it's going to be, but then it's automatically going to offer me that in code. So this data set, I've added a parameter, I've got table name. If I go into my connection and I just click on there, you can see I've automatically get this dynamic content window. So lots of places you've actually got your ability to write some actual dynamic JSON to automatically generate from me. If I just delete that, see down at the bottom of this list, I've got my parameters. So I can just click on that table name parameter and it's going to write that syntax for me. So I don't need to remember that. So at dataset means for my dataset object, that JSON object, I'm going to access the table name property. But again, it wrote that for me. So I've done that. So I've got my Azure SQL database side. On my other side, I need to do the same. So I've got my ADLS dynamic one. So I just need to be able to connect to both sides and have two data sets saying, just tell me the property that you want to connect to. So very similar to how we did earlier, create two data sets, tell them each that they're expecting a parameter, and then tell them each to hook it in. Okay. I've then created a copy of that same copy activity. So I've got the same pipeline, except this time I'm actually going to pass a parameter into it. So on my pipeline, I've got parameters and I've got table name. So I'm telling it that the whole pipeline is going to receive a parameter. So whenever I execute this data factory, I'm going to pass in a parameter saying, this is the table name I want you to run for. And then inside my copy activity, I've got my source and I've got my sink. So I'm saying where to get data from, and it's pointing at my dynamic data set, and it automatically tells me that that needs a pipeline, a parameter. So that's where if you select something, if you select a data set that's expecting a parameter, it'll automatically say, please give me the parameter. And again, you can pick that out and it's got my pipeline parameters automatically. So it allows you to hook this up actually far more smoothly than it used to. I've done the same on my sync side. So I've got my ADLS, my data lake, one set up properly. That again is asking for a parameter. So it's just hooking those bits up. It's saying at the pipeline level, accept a parameter. At the data set level, be expecting parameters, and then get that activity in the middle to pass my pipeline parameter down into my source, down into my sink. So now if I go and run this, it's going to ask me for that parameter. It knows that the pipeline needs a parameter. So I can do my sales LT dot sales order header, and it's going to pass that into my pipeline and then run it using that table. And then that is suddenly reusable. That's now suddenly a pipeline that I can use for any of the tables that's in my source. So if I wanted to run it again for my sales LT address, my sales LT product, or any of the different ones, that's suddenly now a generic reusable thing. But it gets a little bit more advanced than that. So that succeeded, I'm quite happy. So if I go over here, I've got my lake where I was adding data to, and I've got my AdventureWorks with all my various different tables in there. Let's do a quick test. I'm just going to delete that. So if I get rid of all my data from there, just to prove that I'm not cheating. Okay, so I've now got a raw lake with absolutely nothing in it. And then what I can do is build something a little bit more advanced. So I've got a lookup activity. So we said the lookup activity, this is going to use a data set. So it's going to use an existing data set, going to use an existing linked service. It's going to go away, query some data, and get a data set back. I'm then going to do a for each and loop over all the data that that gave me. So in my lookup, I've got a data set, and that's just a generic connection to my AdventureWorks database. And then I'm running a query just to say, select from my sys tables. Just bring back the list of all the tables that exist on that database. And I don't care if I've mapped it at all before. I don't care if it's just appeared. I just want you to go and tell me what are all the tables that exist there and bring it back as a variable. Okay, so that's fairly generic SQL query going off, and that returns an array, returns an object. And then in my for each loop, under my settings, I've got a little bit more dynamic stuff. So I'm saying from that activity, from the activity that I called lookup tables, in the output, I want you to take whatever was the value. So a little bit more complicated. Again, I'm having to write a little bit more of that kind of dynamic JSON, and that's going away and saying, whatever's returned from that query, whatever is actually sort of brought back from my list of all my tables, I want you to recursively run for every single table in there, run whatever I've got inside my for each loop. Okay, so if I get 10 tables back, I'll run it for 10 tables. If I get 500 tables back, I'll run it for 500. And that, if you think about the power that gives you, I can build a very generic thing and then say to my say to the developers of the source system, you know what, if you add a new table, if you add a new data set, that's fine. I'm just automatically going to start capturing it. Now, because the lake doesn't have a schema, it doesn't have any real properties, it can be flexible. It doesn't matter if they add some more data, I'm just going to land it in the lake and that's not going to error. So I'm abstracting away the problem of understanding the data I get from just taking it out of the source system and bringing it into my lake. So inside my for each loop, I've just got one activity that's running. So I'm going to get an execute pipeline. So I'm running that pipeline that we made, my dynamic one. I'm saying, well, for each of these, so each one, I want you to run that dynamic copy to lake pipeline. And then in advanced, it's picked up the fact there's a parameter, and I'm telling it to pass in the name of the current table. Now that's not that well documented, that command. So I've got @item with the brackets, and I'm saying from @item, what's the column inside there? And that particular query that I wrote, it brought back the name column, and I'm saying pick it from there. So now, apologies, that is a little bit more complicated. There is a video of this separately, and you can rewatch this. But essentially, I'm saying for each pipeline run it for each of the values in that database call, and pass it in the name of that SQL table. So what that means is from here, I can just trigger this pipeline. So I want you to run now. Now, it's not asking me for any parameters, because again, this I'm not telling it to do each time. This is going off, talking to the database, and each time finding out what it should do. So each time it's going to change, each time I'm going to figure that out. So I can just click run. And then if we go down to my monitoring table, you can see all the different things that's happened so far. You can see there's currently one pipeline being executed, and then suddenly there's loads. So I've now got lots and lots of different pipelines being executed because it's going through that for each activity. And in each of these, I do have a parameters tab, so I can click and say which table is each of these running for. So I can see it running for my sales order header, running for my customer. So I do have my full audit history of what's been brought into my lake. So I just hit refresh, can see that's now run, they've all succeeded. And I can go to my lake, hit refresh, and I've got this fresh copy of EventureWorks, and it's now brought in all the data. So I've abstracted away the problem of if code changes, if my source system changes, my schema changes, I can still abstract data, I can still get data. Now, sure, if I've got a load of queries I want to run on this, that's not going to work that well. I'll still need to manage that at some point. But in terms of building a generic data acquisition pipeline, I've suddenly built something that's much more powerful. But it does get funkier. How long are we doing for time? Yeah, we're not too bad. Okay, so the big old question is that, what if I don't want to write any code? And that mainly comes from Databricks. So Databricks is a big data processing tool, and it can run in Python, it can run in Scala, it can run in R, and it is incredibly scalable. It's essentially saying if I want to run in-memory big data style processing across 10, 20, 50 different servers at once and actually do some real big data crunching, do I have to learn Python? Do I have to learn Scala? And the answer now is no. So this new feature of Data Factory is trying to address that. How do we do data transformation? How do we replicate what SSIS used to do, the whole data flow element of SSIS, but actually make it properly scalable? Now, one of the problems with SSIS is a single execution can't scale out. So I can't have a series of 10 servers and run a single SSIS package and split little bits of that one package execution out across those 10 different servers. It simply just doesn't work that way. Now, Data Factory Data Flows, because it's using Databricks under the hood, which is essentially Apache Spark, it does work that way. So, don't know if we'll have time for a demo. We can have a quick look. So, mapping data flows looks a bit like this. So you have a couple of streams, you have some inputs, and then you apply transformations to those, and then you have an output. So you build out these workflows of data transformations, and you have lots of different activities that all seem very familiar if you're coming from SSIS. So things like aggregations and pivots and unpivots and aggregates and all the stuff you used to have, you can do most of that functionality here. Essentially, it's more for the slides. It's a way of allowing you to build out transformations in a scalable way. And we see this actually getting more and more functionality. It's still in public preview, so it's not generally available yet. But it's, it looks like something that's it's nearly at that level, and it's pretty cool. So under the hood, what's actually happening is when we build that data flow, when we build out all that logic, that's going to make a thing called a jar file. And because it's a jar file, that means it's using Scala, and Scala is one of the most optimal ways to work with Databricks. And that's going to pass it to a Databricks cluster. Now, it's kind of changed around a little bit how that works. So when you see it, you have this mapping data flow. It actually just takes some JSON. So it's still talking about JSON, the actual data factory, it's still working the same way under the hood. As you drag each of these different transformations onto your pane, you'll see it actually just crafting JSON for you behind the scenes. When it executes, the moment when it executes, it'll turn that into Scala, pass it over to Databricks, and then that'll run on its own Scala cluster. However, when it first came into private preview, you always had to have your own Databricks cluster set up. So you had to be managing that cluster, choosing the size of your cluster, working with all that kind of stuff. Since it went into public preview, it runs on an Azure Data Factory integration runtime. So the auto runtime actually now does Databricks for you, which is cool. One of the things that does mean is that each time it executes, there is a bit of a start time. So if I do one of these transformations and I say, I want to run this data flow, each time I hit execute, it's going to have to wait for 4 or 5 minutes waiting for that Spark cluster to turn on. Then it'll run it and then it'll turn off automatically, which is great. But there is a bit of a delay. Now we're expecting that to get a little bit better. We're expecting that to give you a bit more choice. And we'll see things like how long should it stay on until it turns off. And so if another data flow tries to execute and another data flow just run, it'll try and piggyback on that same cluster. So there's going to be more management stuff coming in. But again, it's a little bit early days. It's not GA yet. So expect to see more stuff there. And then there's even more stuff coming. So that is a thing called a mapping data flow. And that is entirely brand new. No one's actually sort of, it's quite rare to see it anywhere near production yet because it is still in preview. But there's a new thing that's even more in preview, that's in private preview, called wrangling data flow. Now, if any of you are big Power BI guys, then you'll be very familiar with this because it is just Power Query. They've even got the same logo. So if you're actually sort of doing this and you're looking at it going, well, actually there's that mapping data flow. Sure, it looks quite cool. It looks, it's got a lot of functionality in it, but it's a whole new way of working. It's a whole load of new expressions and languages and ways of working to use. Well, it's actually going to get a lot easier if you're familiar with Power Query. So there's this new version coming which replaces that with the exact Power Query thing out of the box. So we're going to see that kind of very, very soon. It's like so slowly kind of moving into public preview, hopefully. And then you've got that choice. So if you're using Data Factory and you want to do data transformation and you don't have another tool set up, you're not using Databricks, you don't do things in a database, and you want to do this kind of transformation of data and have it built in to your Data Factory, then either mapping data flow or wrangling data flow are probably going to be the tool that you can use. Now, mapping, when it was first announced, was very, very quite static. So it's very much going back to that old idea of saying, I'm going to have a transformation for each of my different files. So we'd have a bit of a mix of some dynamic pipelines where I don't just had one pipeline doing lots of different stuff by passing parameters in, and then lots of copies of similar transformations in mapping data flows kind of repeated quite a lot. But actually what we've seen over the past couple of weeks is lots more parameter-driven stuff coming into mapping data flows. So I'd expect to see some of that stuff, again, able to do it in wrangling. So you've kind of got lots more things coming in, lots more kind of transformation options, lots more ways of working that's slowly kind of creeping out and appearing as we go. So very, very, very quickly, I'm going to show you a peek of where it lives in Data Factory. And then we'll see if anyone's got any questions. Okay, so inside my Data Factory, I did have that one bit at the bottom, which is that Data Flows Preview. So if you're trying to do a data flow, you're trying to create this logic, you still need to use pipelines, you still need data sets, you still need linked services. It links straight into the entire ADF estate. It is part and parcel of using Data Factory. So I've got a very quick example here, which is just doing something fairly straightforward. I'm just making a product dimension. So from that AdventureWorks run, from all those files I brought off, I've got a product category, and a product model. And I'm just doing, essentially, I've got a source for each of those, and that's referring to different data sets. So I've got a sales LT product, a product category, and a product model, and I've had to set those up as data sets in advance. So I'm telling my mapping data flow, that's where to get your data from. I'm doing a select. Select's a way of just manipulating which fields I need. So I can say, actually take product ID and renaming columns and removing a load of columns. There's 13 columns that I didn't want, which I've now unmapped. So I'm kind of just selecting which data I want. And the real cool thing that came in, I think only a couple of days ago, is I've now got these thing called rule-based mappings. So even if my data isn't entirely different shape, I can say, well, actually go and find the column that has email somewhere in the name. So if I'm trying to say, actually, I've got loads of different data sets, can I just pull out a generic set of emails? I can do rule-based mapping to say, if it has an email somewhere in the column title, add that to a new data set and call that email and then pass it on to a transformation stream. So this has suddenly got really funky and really quite generic. I'm doing some lookups. Again, very similar to SSIS lookups. I'm telling it, join one stream of data to another stream of data. So I want to augment my product with my product category. And I've got details about how I optimize that. So I can actually tell it on the Spark cluster how to organize those different data sets, how to split it up across my different nodes in my cluster. I can tell it to broadcast. So I can actually say, you know what, my product category is really small. Why not just make a copy of that on each of my different nodes, and that's going to optimize the speed of it. So I've got quite low level amounts of control over the transformation that's doing, knowing that this is using Spark in the background. Then doing a final thing to tidy up my data, and then writing it into a sink. And this is a fairly contrived example of just combining a few data sets, but if you think about some of the different transformation options that we use, it's actually quite deep and quite powerful in terms of what we've got. Another thing to very quickly show is I've added a derived column, and it tells me how it works. Okay, so if I go for my expression, I have a very rich query editor here. So the expression I can do to actually apply logic to create new columns and create calculated columns is an incredibly deep and rich query language. So there's a whole world of stuff that we can do in here to actually sort of just add a whole new functionality. Now, there is a debug mode. So I can actually sort of, as I go, as I change my code, as I try out different stuff, I can hit go and just say, what does that look like now? Now that does need a cluster running in the background. So I've got kind of a little Dataflow debug button right at the top. If I click that, I'll wait a few minutes and then there'll be a Spark cluster running in the background and I can start to step through and see how this changes things. Beware, that does cost you money. So it's a very small cluster that runs, but it is going to cost you. But it actually provides some quite detailed viewpoints of what's going on with your data. And then finally, when you want to use it, there's just this new data flow activity. So I think it's in move and transform. You've now got this data flow. So you pick your data flow, and then in settings, you just pick of the data flows that you've corrected that are over on that left-hand side, pick the data flow that you run, pick where it's going to run, and then that's going to run your data flow for you. So it's actually baked very closely in. If I just find where I ran that earlier, which I think is that one, I can go down and have a look at what actually happened inside that data flow. And then I've got a button to actually show me in detail what happened at each of those stages. So I can see how many rows it was working with at each level. I can see how that balanced. If I was running it on a multi kind of server cluster, I can see how it actually managed to do that. If there's a massive amount of skew because of the way I joined it, I can get down into real low level information. So it's cool stuff. So if you haven't already, I definitely advise having a look at mapping data flows. So if you've got a V2 data factory, you'll see it there. You can go and have a play. You can go and work with it. Again, you don't need to have any Databricks knowledge behind the scenes to take advantage of Apache Spark and its massive scalable glory. Cool, so that was all I wanted to go through today. So if you've got any questions, then feel free to ask them now or get hold of me on Twitter, or we've got a load of stuff on the blog if you want to go and get any more details. So I guess I'll see if we've got any questions from the audience that we're waiting on.
Nice. Yes, we've got quite a few actually.
Okay, good.
So first one comes from Daniel. Daniel would like to know, how would you be able to move data from an on-prem environment into a managed instance?
Oh, into managed instance is painful. So as far as I know,
not the answer he was looking for.
Yeah, I know. So because managed instance can actually talk to a VNet, then you can use a self-hosted integration runtime to talk to both. So you need to have that integration runtime able to see both your managed instance and your source server. So it's a little bit clunky. It won't actually go up into kind of and use the copy data elements of Data Factory itself, but you can do a Data Factory copy as long as both can talk to that that same integration runtime. I've not tried it if you're passing from one integration runtime to another integration runtime. I don't know how that'll work. So if you're trying to move from an on-premise environment to an entirely disconnected environment that's using managed instance inside its own VNet, like you could place a self-hosted integration runtime on both sides, but I have not tried that out yet.
All right. We've got a two-part question from Saeed. So you would like to how to execute a T-SQL task using ADF. He is currently executing a store procedure activity on an Azure SQL MI using ADF. There is no copy activity involved in his process, so he cannot use the pre-script option. He requires to drop and create schemas, tables of views, store procs functions, etc.
Okay. Yeah, I mean, so you do have the ability to run store procs, and you have the ability to override that. So if you've got let's see if I can get it up. I don't have that example set up, but let's have a look at what we can see. So if we've got something that's just calling a stored proc, I'm going to break my thing now. So inside the stored proc, when I'm having a play with what that's actually doing, I can override that and kind of change around what it's actually doing. So you can do dynamic stored procs. You can have it kind of running dynamic bits of code. So I kind of generally do that. If you want it to run just any bit of T-SQL, you can do that. It's kind of a bit more of a hack in terms of you can kind of tell it the source of a copy is a query, and then you can give it any old bit of SQL to run, but that's not particularly great. Generally, I would create various different store procs that it needs to do, encapsulate that inside the store proc logic, and then be dynamic about how I pass parameters into it and how I change that works.
Cool. And I think the next question is based onto something like what you got. So he's saying he's got a set of stored procedures that execute in his ADF. He's using an ADF for each loop. When the pipeline is executed, the names are coming through as activity 1, activity 2, etc. But when a stored procedure breaks, he's having a problem mapping the two. Is there a way to rename the activity so that they actually have the name of the stored procedure?
Yeah, so that is a bit of an awkward point. So one bit of advice first. So inside a for each loop, if you get any breakages inside that for each loop, then it's kind of awkward to debug, especially if you've got more than one activity. So if I'm inside here and I go to edit activities, I can have a whole chain of stuff going on in here. But if one of those activities happens to break on one of my particular lines, it's really not great at bubbling that up and saying what's actually gone wrong. So the example I set up here is because I've got all that logic in a separate pipeline, then that means in the monitoring window, I see it as a separate execution. So it's not as easy. It's not particularly nice. All my pipelines are called the same thing, but at least I'd be able to see which ones failed and then have a look at the parameter that was passed to that to find out exactly what went wrong. Plus, inside each of those pipelines, I can add its own debug logic, its own fail logic, and all that kind of stuff. So absolutely 100% whenever you're using for each activities, I'll definitely try and pass that into a child pipeline that actually performs that logic, because it does make debugging it a hell of a lot easier. Even though, yeah, it'd be nice if we could have that pipeline name dynamic and change for each of the inputs.
All right. Okay, so Jose would like to know is, can you do transformations on the fly, or are all the transformations happening after you have moved data?
So it's generally happening after. So via mapping data flow, you can do transformations on the fly. So it can pick data up, do transformations, and land it. The number of linked services that mapping data flows has is currently quite small. So it can talk to Azure SQL DB, Azure SQL Data Warehouse, Blob Storage, and Data Lake Store Gen 2. I think that's all the linked services it can do. So if you're doing the go back to a source system and grab data, bring it into Azure and transform it on the fly, then generally no, you'd have to land it somewhere. But that's generally a pattern I don't recommend anyway. Because one of the age-old things you get people doing is everyone has an ETL window and they only ever process their data between midnight and 3 a.m. because that's the only time they're allowed to touch their source system. And if something goes wrong with that transformation, if something breaks, they have to go back to source and then extract it again. And maybe they only see that breakage during the day, and then they're not allowed to repeat that data load because they're not allowed to touch the source system during the day. There's all sorts of problems about trying to do that extract and transform as a single step. So from a design practice, kind of a best kind of practice kind of point of view, I'd almost always just abstract the data, land it somewhere, and then transform it once it's in Azure. Especially if you're using those dynamic acquisition patterns, you just have that one thing to go and suck all your data up. And then, yes, if a transformation thing fails down the line, you need to rerun it, but you're rerunning it from a saved landed point in Azure. You're not re-uploading that to Azure and going back to your source system. So there aren't that many ways of being able to do that lift and shift and transform on the way, but I also wouldn't recommend it.
Cool. Okay, Jose would also like to know, what are the main differences or similarities between ADF and Microsoft Logic apps?
Okay, so some of the Data Factory things are kind of built on Logic apps in terms of some of the newer decision-making things. Now, they do have some similarities, but generally it's about how long you want to be running. Now, Logic apps is kind of a message-based system. You want a quick, snappy decision that say, something's happened, what should I do? Make a decision, go. You don't tend, it's generally a bad practice pattern to have a Logic app that's sitting there running for half an hour waiting for a job to finish. So, Logic apps, you could see it running, I've got 1,000 different messages coming through and I run a Logic app for every 1,000 of those messages. And if I was dealing with that small amount of data, I wouldn't want to spin up a data factory for that because there's an overhead. So kind of Logic apps are small event-based decisions that need to trigger off another thing in a kind of asynchronous fire and forget style. And data factories are more orchestration things that are looking after long-running jobs and managing chains of things that are working between it. And I tend to use both of them quite a lot. And one of the patterns I tend to use, Logic apps sees something happen, makes a decision of should that start some data processing, and then kicks off the data factory to do the longer data processing. And maybe even you've got a chain going on. So when the data factory finishes, it fires a Logic app that decides if it should kick off the next chain. You can have nice logical decoupling of your various different data processing steps using Logic apps as that decision maker in the middle.
All right. Okay, then Wajid would like to know, what is the best and cheapest way to learn about ADF? I think somebody has a nice 30-day series coming up. Well, you actually finished, right?
Well, so that was a month of Databricks. It wasn't Data Factory.
Oh, yeah, sorry.
I might do some Data Factory training at some point. So yeah, there's lots of online tutorials. There's lots of kind of online help. The documentation is actually really, really thorough and detailed. But in all of these things, I'd say kind of probably the easiest way is just to have a crack and give it a go. So there's some decent web tutorials that kind of give you a bit of a starting block. But if you don't have an Azure subscription, then you can sign one up and I think you get, is it 90 days of £100 a month, something like that? You can sign up and get a little bit of money for a couple of months. And if you've got a MSDN account, then you can automatically register with that and get, I think it's $150, I think was the original amount, that you just get to spend in Azure and play around with some stuff. And I just say just try and do some of your traditional ETL stuff using it, because actually when you get started, it's sure some of the syntax and some of the weirdness around the dynamic stuff is a little bit complex and can be hard to find out how that works. But the starting stuff there, I'm trying to copy data from one place to another. I'm trying to, kick off a series of store procs. Best way is just to spin up a data factory, have a go, because it's really low cost and you can do it on a trial thing really easily.
All right. Okay, so we're getting a couple more questions, but we're actually out of time. Would you be happy if I sent you these and you wrote them up maybe in a blog post? And then you can send
absolutely.
that out? Okay. All right, so thanks so much for coming to talk to us today. It's been fantastic. I hope everybody learnt a lot. When the session ends, everybody, you're going to get a short sort of survey. Please fill that in. That helps both our speakers and ourselves improve and bring you more content. If you have any suggestions on topics that you'd like to hear about, as well as if you would like to talk, make sure to mention that in the survey as well. So once again, Simon, thanks so much, and we'll be in contact soon. All right.
All righty.
Thanks, everybody. Cheers.